session that we'll have, then safety committee members will then show it to the other people in their departments that's not able to make the training. So if you would, hold your questions until the end if you have them, because we won't be able to stop the video and start it back up. And I understand that Susan will maybe do some interacting with
Sure.
You all.
Especially if you look like you're falling asleep.
Yeah, but if the questions, if you would hold them until the end, we'd be happy to answer them if you have them. Thanks, y'all. Susan?
Okay, thank you. Well, good afternoon, everybody. My name is Susan Beard. I've been married to Murray for 26 wonderful years, and I'm a native Memphian, and I'm currently the Vice President of Plant Operations at a Memphis chemical compounding plant, and as part of those responsibilities, I am responsible for all compliance issues, including OSHA. So I do the training at my plant. Part of what we do there does involve blending end-user products, some of which are hazardous. So I am not only responsible for training my employees on how to properly handle the hazardous raw materials that go into those blends, but I'm also responsible for making sure that the labeling and accompanying what used to be called material safety data sheets and will begin to be known as just safety data sheets pursuant to this new set of regulations, making sure that those are correct. Because if they're not correct and someone gets injured, then of course my name is on all of that paperwork, and I don't want to spend any time in jail for that. So I do try very hard to make sure that I am up on the latest safety issues, things that are coming down from OSHA and whatever other government entities are involved in those things. So are we ready to start? Everyone ready? Okay. So we are here today to talk about the new globally harmonized system of labeling for hazardous materials. Okay. The point of this changeover to this globally harmonized system is so that anywhere in the world you should go to work. If London, England calls Collierville and says, we desperately need some of your employees to come help us, even though you're leaving the United States of America, when you come in contact with a hazardous chemical, you will be able to recognize all of the things on that label that tell you that that chemical is hazardous and how to handle it appropriately so you do not become injured. So it's as the name implies, it's a global standard. The United States is coming into compliance with standards that are already in place in Europe, and it's simply a desire to make sure that all employees are as safe as they can possibly be in their workplace. Now, some of the objectives this afternoon is primarily to make sure that you can recognize when a chemical is hazardous, to understand the specific risks that that chemical poses, to interpret the information that is on that label so as to minimize your risk, to understand the information contained in the safety data sheets, to, of course, protect yourself from any physical or health hazards posed by those chemicals, and then how to respond to any emergencies that might arise from that chemical, such as a spill or contamination. Now, many of you, in fact, I would say most of you, probably already know quite a bit about this subject, whether you realize it or not. Okay? So here's just a list of statements that we're just going to work through just to kind of test where your knowledge is right now, all right? So under the globally harmonized system, OSHA will no longer regulate workplace hazardous chemicals. Just in your mind, think true or false. OSHA is no longer going to regulate hazardous chemicals in the workplace, true or false? And yes, that's very correct. That is false. Go back. Okay. I definitely have the gift of anti-technology. Hazard communication applies to chemical manufacturers only. Is this my responsibility as a manufacturer solely? No needling from the peanut gallery there. Okay. Safety data sheets are better organized and may provide more information than material safety data sheets. Well, that's a trick question. Let's see. Very good. True. Okay. PPE, personal protective equipment, is required only if you spill it. I think that's going to be correct. And the pictograms on a label convey specific information about the hazards of a chemical. Okay. See? Y'all got all of those right. You already know. I can stop now because you already know all that. No, we're going to keep going. Okay. So where do we encounter hazardous chemicals when we're working? Just about everywhere. Just about everywhere. Even people who are in here who work only in an office environment, the toner in your copy machine is hazardous. And you should have an SDS in the office detailing the hazards of it. Okay, so it can pop up in all sorts of places where you least expect it. Anytime that you go to fill your vehicle with gas, you're encountering a hazardous chemical. When you use liquid cleaners, they can contain hazardous chemicals. Not all of them, but some of them will. Anytime you use a solvent or an acid, and of course antifreeze. Antifreeze is very hazardous. You need to keep it away from your children and your pets. Aerosol sprays. Just the fact that it is an aerosol means that it is a hazardous chemical. The properties that make it an aerosol are hazardous in and of themselves. Okay. Spray paint, insect repellent, any of those that are aerosols. So why is it important that we prevent these hazards from impacting you in your workplace? Because there are many, many, many instances of people whose lives have been lost or severely impacted by improper use of hazardous chemicals, either because they just didn't know that the chemical was hazardous or they didn't know how to react to the incident with the chemical. Okay? Over 880,000 hazardous chemicals are used in the United States. That's a lot of hazardous chemicals. 50,000 work-related injuries and illnesses with 125 fatalities annually. And those are the ones that are properly reported. So OSHA has developed what's called the Hazard Communication Standard. Okay? And the most recent amendment to that is known as HazCom 2012 because it was the final version of it was published in the year 2012. HazCom, Hazardous Communication. This says that your employer must provide you with a written hazard communication program. And it's my understanding that each individual division and department within the town has their own personal hazard communication program, simply because each department has job-specific hazards that other departments don't have, and so each department has one. You should be able to access this either through your direct supervisor or through whoever is the health and safety officer in your department or division. Also, there should be a list of the hazardous chemicals that you are going to encounter working for the department of the town that you work for. This could be a separate list, or it could simply be the alphabetical index of safety data sheets that are maintained within your department on the chemicals that are present in your department. So there's several ways that could show up. To provide you with the safety data sheets. Anytime you are dealing with any chemical that is hazardous, if you are unsure how to handle that chemical, you can go to your supervisor or your health and safety officer within your department and request to see the safety data sheet, and they should be able to produce it for you so that you can look at it and be sure that you're going to be safe using that chemical. And of course, you can look at the label on the container, and that HazCom 2012 standards that are harmonizing how a label looks is intended to make it easier for you to read the label and immediately know what hazards might be present in that chemical. So as a manufacturer, my job is to make sure that my labels are standardized so there is never any doubt on what panel of the label to look to figure out what the hazard of the chemical is. That's my job, and I have a little bit longer to get that done. This training is required by the 1st of December this year. Manufacturers have until June the 1st of 2015, but I believe that what you're going to discover is many, many manufacturers and distributors are already producing chemicals that have the new globally harmonized symbols and descriptions on them, which is partially why OSHA wanted your training to happen sooner than my requirements to produce those labels. I am already getting requests from my customers to not send them products without the globally harmonized standards being met on the labels. They won't accept anything that's not to the new standard after April the 1st of 2014. So we're already beginning at my place of employment. Also part of the Hazardous Communication Standard is to provide this training for you. Any ongoing training should occur whenever a new hazard enters your workspace or anytime a new employee joins the department. They need to be trained on the hazards of the chemicals that are present in the workplace. And all of this is part of the requirements of the Hazardous Communication Standard. So what is GHS? As I've said, it's the globally harmonized system of classification and labeling of chemicals. Implemented through OSHA's HazCom standard to provide a universal approach to identify hazardous chemicals. Now, your employer responsibilities I've already enumerated. The requirement to communicate to you the presence of hazardous chemicals in your workplace. But as an employee, you also have responsibilities. You are responsible to read and understand the labels and the SDSs on the chemicals that you work with. Okay. To follow any job-specific instructions or warnings that you might receive from your supervisors in using, storing, or handling those chemicals. And to always identify any hazards before you begin the job. This is very critical. You would never begin a job without first verifying that you have everything that you need to do the job. And you should also never begin a job without verifying that you completely understand all of the things you're going to use to get that job done. And that includes the chemicals that you use. Even if one is a familiar chemical, one that you've used numerous times before, it never hurts to do a quick review of the label just to make sure that nothing has changed. As a chemical manufacturer, I can tell you, we reformulate fairly often. as new chemical technology becomes available, as a new understanding of how chemistry works in different situations, it is not unusual for us to reformulate, which means that possibly the product you have been using for 10 years, day after day, is now different. And you need to check the label and make sure that you know how to properly handle it. And you are also responsible to participate in any training that is offered to make sure that you are up to date on how to handle things. Okay. So what forms can hazardous chemicals take? What are the basic forms that you might encounter them in the workplace? They can be a solid, a liquid, or a gas. Just because something is a solid brick doesn't mean that it doesn't contain hazardous properties. It's not just liquids. Now here's a long and detailed definition of what a hazardous chemical is according to OSHA. Basically, anything that contains 1% or more of a hazardous component by formulation. Now again, as a manufacturer, that's my job to determine whether that formulation contains 1% or more of a hazardous chemical. Okay? That's not something that you need to worry about, okay? But that's what is the definition of a hazardous chemical, 1% or more. So what is a physical hazard? Okay, hazardous chemicals can pose physical and or health hazards. So let's talk about physical hazards first. Okay? Any chemical that has been scientifically proven, okay, to contain any of those properties, that it's combustible, as in a liquid, a compressed gas, it's an explosive, it's flammable, organic peroxides, oxidizers, pyrophoric chemicals, any chemical that is unstable in various atmospheres or that reacts with water. Okay? Those are all considered physical hazards. They impact the physical environment that they are used in, and so they pose physical hazards. And there are the attendant pictographs that go with each of those physical hazards. And we'll go over each one of these pictographs individually. Okay, so what do we mean by a health hazard? Well, the OSHA definition for this takes up about 4 pages in the 29 CFR, so we're not going to sit through that. Let's just define it, summarize it here. Anything that causes short-term or long-term effects in your body that are not good effects. If it's toxic, poisonous, if it causes skin corrosion or irritation, eye damage or eye irritation, if it causes your respiratory system or your skin to be sensitized, anything that affects your DNA is definitely a hazardous chemical. Anything that causes cancer, anything that affects your ability to reproduce, anything that targets a specific organ in your body, such as your kidneys, your liver, or anything that is a hazard if you should breathe it in. That is what a health hazard is. So it affects you internally in your person as opposed to your physical environment. And here are again some of the pictographs that will indicate these hazards. Other chemical hazards is asphyxiation, or the inability to get enough oxygen into your body. Some chemicals their vapors are heavier than air, and they will displace the oxygen in your lungs if you breathe them in and take up the room in your lungs that's normally occupied by oxygen, by the air that we breathe. Okay? So there would be no room in your lungs to take in the air that you need because that room is being occupied by the vapors of that chemical. Okay? Okay. A pyrophoric gas, this is one that spontaneously combusts at any environmental temperature of 130 degrees Fahrenheit or below. Okay. I don't think we hit 130 yet in any of our summer temperatures, but we get pretty hot. And most people would think that only high temperatures would cause spontaneous combustion, but these sorts of chemicals can combust at a temperature that we have today. So you need to be aware when you are using them. And combustible dust. Sugar produces combustible dust, believe it or not. So we should always check our labels and not assume that we know whether something is hazardous or not. And then there's this catch-all phrase, hazards not otherwise classified, which there's an entire section in the OSHA HAZCOM 2012 standard about this, and I'm sure they'll be adding to it. Now, one of the important things that has to happen when you're dealing with hazardous chemicals is the ability to detect the presence of hazards in the environment and then to monitor the levels of those hazards. So the visual appearance can be one clue. Are you seeing vapors? You know how the air gets wavy if there are vapors? Do you see that? Is it possible that this chemical is releasing vapors that could be hazardous? Okay. One way that this can be detected is with continuous monitoring. I believe that some departments, specifically I'm thinking of the water treatment department that you guys deal with chlorine gas, I am sure that you have a continuous monitoring system in the facility where the chlorine is stored and used. Okay. Sometimes odor is an indication that there might be a hazardous vapor present. You can't count on this one, though. There are many hazardous chemicals out there whose vapors do not have a detectable odor, all right, but some do. Okay. The foundation idea here is that you should know what hazardous chemicals are present at your facility, in your workplace. You need to know where they are. Okay. If you're walking through an area and you're unaware that there's hazardous chemicals used or stored in that area, you could be at risk. Every department should have a specific area where hazardous chemicals are stored, and they should be stored properly dependent on the requirements of that particular chemical, such as flammables need to be kept locked in a flammables closet that is appropriately built to withstand the possibility of a fire so that it doesn't spread, that sort of thing. So know where the chemicals are. Know where to go to read your written HAZCOM plan. If you have never read the HAZCOM plan for your department, I would urge you to do that. Okay? Also, the chemical list for the chemicals that you come into contact with in the department that you work in should be with your written HAZCOM plan. The SDSs for the chemicals that you work with. You should be familiar with them, and we're going to look briefly in just a little while at how the information on an SDS is organized. Now, hazardous chemicals enter your body through several different routes. Through contact with your skin or your eyes, through inhaling the vapors or dust, through ingesting them. Whoop, red flag. I don't eat the chemicals that I work with. If you don't wash your hands after you use those chemicals and before you eat or smoke, you are possibly ingesting those chemicals. If they are on your hands, you pick up your sandwich and you take a bite of your sandwich, you have now ingested that chemical. So yes, ingestion is a definite route. Or absorption. This is why all first aid requirements will tell you to immediately flush your skin or eyes with water, usually for 15 minutes, could be more depending on the chemical. You do not want to leave a chemical sitting on your skin. It can absorb through your skin. Your skin is a porous surface, and that can be absorbed into your body. Okay, little test. GHS replaces OSHA regulations. True or false? False. GHS is part of the OSHA regulations. It's just been an amendment to the existing regulations. Okay? I am not even going to try to pronounce that first word. If I think about it hard, I can do it, but I don't want to think that hard. Something that causes cancer, we'll give the definition, is a health effect of a hazardous material. True or false? True. Under HazCom, you must know how to read the SDSs. I'm hearing true. Yep. Y'all are right. Why did it do that? There are a total of 5 million workers potentially exposed to hazardous chemicals in the United States. No, there's 43 million. GHS is intended to standardize the information about hazardous substances for people all over the world. True, yes. True. Very good. You pass. Okay, so what have we learned so far? Do you understand why it's important that you're here today? Because we want you to be safe. I live in this town. I appreciate everything that all of you do to make my town a beautiful town, and I want you to be safe. And the town wants you to be safe. It's very important. Do you understand where you can encounter hazardous materials? Anywhere. Could be anywhere. That there are physical and health hazards involved with using hazardous chemicals. How about how hazardous materials enter your body? Those routes that we talked about, skin, eyes, absorption, inhalation, those routes. Everyone clear on all those? Okay. Do you understand your responsibilities as employees under the HazCom standard? To educate yourself about the hazardous chemicals that you're using. All right. Now, one of the first ways that you're going to begin to determine whether a chemical that you're using is hazardous is to look at the label. So we want to take a moment and look at the new standardized format that you should begin seeing, if you're not already seeing it, on the labels of the chemicals that you're using. First of all containers must be labeled. If you go to use a chemical and the label is not legible, you need to let your supervisor know. Your supervisor can contact the manufacturer and request additional label copies. I do this every day. I get phone calls, emails, faxes. Hey, we need 3 copies of the label for this particular product because we can't read them anymore. I am happy to provide those, and we do not charge for them. Hopefully, your other vendors don't either, but it's important that you have legible labels on all your containers. Even portable containers. Now, the caveat on this is that if you are pouring into a smaller container for your personal use on that particular shift, and that container is never out of your possession, you do not need to label it. However, if you have product left in that container at the end of your shift, you either need to pour it back into the original container that it came out of, or you need to get a label for it. This can be difficult because if you need to label a small portable container, that label must have all of the information that the label of the original container has. So if you have a large 55-gallon drum that has a lot of information on the label and you've poured that into a 32-ounce trigger spray bottle, that's going to be difficult to do. It would be much better to pour that product back into the original container rather than try to create a label for it. Okay? So let me repeat that because that's important. If you pour out product into a portable container and you use that product completely on the shift that you poured it out during, and that's an important and, that portable container remains in your possession for the entire shift, you do not need to label that container. Is that clear? It's a really critical thing. Because if you have a chemical that looks like water and you've poured it into a bottle that looks like a water bottle and you've laid it down and left it somewhere, and your coworker thinks he's going to play a joke on you and drink your Sprite, that's a problem. And we don't want to do that to each other. We want to make sure that we keep each other safe. Okay, so what is on a chemical label? Now, this is not a required format. OSHA has not said that every chemical label must follow this exact format. However, this information has to be present on every label. You may see it in different places on the label. If you've got a long, thin label, it may all be columned out across it, not necessarily like this, but you should be able to find every piece of this information on every label. Okay. We're going to look at some of them. The first thing that you're going to see is the product identifier. An easy one would be Windex. The product name would be Windex. Now we know from using Windex that the label on Windex sitting on the shelf at Walmart does not have the title product identifier above the name Windex. So that's one way that labels are allowed to differ. Okay? But the name of the product is going to be there. Okay. The next thing to look for is the hazard statement. This should be close to the pictogram. If you'll look above that circle, you'll see some hazard pictograms. Anyone want to guess what those two pictograms are telling us? There's a health hazard, and it's an oxidizer, meaning it provides more oxygen to make a fire burn hotter and faster. That's what an oxidizer does. Oh, is that a flame? Sorry, I'm looking at it sideways. Flammable. Yeah, the circle, yeah. I've got to get my bifocals in. Okay. Once you've decided that a chemical is hazardous based on the hazard statement and the presence of any pictograms, then you should immediately begin looking for your precautionary statements. Okay, these are statements that tell you how to store it properly, what things that you need to avoid storing it with or using it around, any health precautions that you need to take, which might help you determine what PPE you need to wear before you handle it. And then usually you're going to see some standard safety precautions, such as do not eat, drink, or smoke when using this product. That's a fairly standard one. The manufacturer may provide some supplemental information. Usually, I would think you would find directions for use. Okay. You might also find additional information. You may find here some pictograms of the PPE that the manufacturer is specifically recommending that you use with the product. This is an optional area for manufacturers. It won't always be there, but it's worth looking for. Just an extra step to keep you safe. Okay. The pictograms, of course. In fact, I would suggest that be the first thing you look for, is the presence of a pictogram on a label. If there's a pictogram on the label, that's usually a good sign that you need to stop a moment and glance over the rest of the label, because it's probably telling you that it's hazardous. There are all the possible pictograms there across the bottom of the screen. Supplemental information we talked about. The signal word. Okay. This is the first time that OSHA has mandated a signal word. Up till now, it's been up to the manufacturer to determine what word, if any, to use to indicate that there's a danger with this chemical. Going forward, there are only 2 signal words allowed: warning and danger. Warning you will see on products that are less hazardous, and danger on products that are more hazardous. This determination, again, is made with some fairly complicated formulations and tables that OSHA has provided to manufacturers, and your manufacturer will have made that determination. But looking for those words is a good way to know whether this is really dangerous, it'll say danger, or just a little dangerous, and it'll say warning. You will never see both of those words present, because a chemical can't be a little, a lot dangerous. It's either going to be one or the other. Okay. Pushing off into the various pictograms. The skull and crossbones. This one, I believe we're all familiar with. I remember the little green stickers when I was a child that they tried to get all the moms and dads to stick on products. They had the skull and crossbones on it. These are for poisons. Okay. Generally, you're going to see this when there's a chance that you're going to die if you get this chemical inside your body in some fashion. When you see this pictogram, if you are not extremely familiar with the product, please be sure to read the label thoroughly. Oxidizers, which is what I thought the other pictogram was. Circle with the flames on it. Oxidizers can be solids, liquids, or gases. Okay. The list there gives you some examples. Again, if you see this symbol, it means that if there's a fire and this chemical is present, that fire is going to burn hotter and it's going to burn faster. There are special firefighting techniques that go into how to handle fires involving oxidizers. If you have not been trained how to do it, run. Your fire department has been trained and they can handle it. The exploding bomb. This is my favorite one. Looks like something out of a DC Comics. Okay. Meaning this chemical could explode. All right. It's reactive in some fashion. Any sanitation department people, if you're using a caustic powdered sewer solvent, the caustic in that product reacts violently with water and can cause an explosion, cause it to blow up into your face. Okay, just one example. Or it could even explode if it's accidentally dropped. Hopefully, y'all aren't dealing with any of those, because those are some pretty bad customers. Okay. The next pictogram is that this is corrosive, meaning it could be corrosive either to metals or to your skin or other parts of your body. Definitely corrosive things cause eye damage, more or less severe depending on how much you get in your eye, how quickly you get it out, and the strength of the product. Okay? These are not things you want to play around with. With corrosives, You have very real storage issues. You do not want a corrosive stored next to an oxidizer or a flammable. Your department health and safety officers should be aware of those things, and they should make sure that you are properly trained in where to return those chemicals to storage when you are through with them so as to avoid any dangers from those. The gas cylinder for compressed gas, liquefied gas, refrigerated gas, these can explode if they're heated. If the valve comes off because the cylinder is dropped or for any other reason, it can become a missile. I have seen that happen. It's not fun. They can go through concrete block walls. So you can imagine what would happen if you were between one and a wall if the valve came off. Okay. Health hazards. Now, this is a standard pictogram. The pictogram itself is not going to indicate to you which particular part of your body this chemical could harm. But when you see it, you should most definitely proceed to the precautionary statements part of the label so that you know in particular what effects that particular chemical can cause. And it could be any of those listed. Again, it could cause cancer with repeated prolonged exposure. It could affect your DNA and cause birth defects in your children. It could render you sterile. Usually these effects are after, again, prolonged exposure. Respiratory sensitivity could target specific organs so that they don't work as well in your body and do the job that they're supposed to do. And it could cause chemical pneumonia. Those are all some of the possible health effects when you see this particular pictogram. The flame, flammable or combustible materials. Of course, a flammable material is anything that has a flash point under 100 degrees Fahrenheit. If it flash points in a closed cup over or equal to 100 degrees Fahrenheit, then it's considered combustible, meaning it does not catch on fire as easily. That does not mean that it will never catch on fire, just that you have to work a little harder at it. Okay? Definitely a flammable material is going to have the warning signal word danger, and a combustible material will have the warning word warning. The exclamation mark indicates that this has the possibility of being an irritant, a sensitizer, could be toxic, could cause a narcotic effect. That means it can make you feel sleepy, or it could irritate your respiratory system. This pictogram is optional. OSHA is not requiring it to be present on labels of chemicals that are toxic to the land or the aquatic systems. Okay. It's recommended, but it's not mandated. I would say that the majority of chemicals where this pictogram might show up or ought to be there if it's not are going to be things like soil sterilants, pesticides, those sorts of things. Copper sulfate is frequently used in the sewer systems to burn out tree roots. Okay? Copper sulfate is an environmental toxic. It's being phased out. But you may not necessarily see the pictogram because it is optional. They're not requiring it. Everyone clear on the pictograms? I think they're fairly self-explanatory. Okay. All right. Let's move on to the safety data sheets, SDSs. Currently known as material safety data sheets, soon to be known as safety data sheets. I imagine it's going to take me a good decade to stop calling them MSDSs, but I'll work on it. Safety data sheets for all of the hazardous chemicals that you encounter during the course of your workday must be made readily available to you. They should be somewhere in your department headquarters, and again, if you don't know where they are, ask your direct supervisor or your department's health and safety officer. You should read the SDS before you work with any hazardous materials. The SDS contains a detailed written description of the hazard. The precautionary statements that are present on the labels may not and frequently will not be comprehensive. They're going to be just enough to clue you to the top things you need to know. The SDS is going to contain everything you ever wanted to know about that chemical and probably a lot that you don't care about. But you should read it anyway. Because it's going to describe all of the risks, all of the precautions you should take, and any first aid remedies that you're going to need to know if you should get it on you, spill it, or otherwise have some sort of incident with it. So SDSs replace MSDSs. They're going to a new required 16-section format. Previously, MSDSs were only required to have 10 sections, so there are 6 additional sections to further spell out any of the properties of the chemical. Okay. So they're going to contain a more complete amount of information than the label will, or the prior MSDS. Okay. So 16 sections. We're not going to step through these. I'm just going to flash them up there. So y'all pick a board and take a look. Oh, heavens, where did 2 go? 2 is missing. Oh, so is 5. Hello? 7. Oh. They're playing mind games with us. Oh. Hello? Okay. Wow, I hope there's a single slide that summarizes them. No. I would suggest that as quickly as possible when you leave this training that you go find an SDS and glance over it so that you can see the summary of everything that is on there. All right, written HAZCOM plan. And we've already talked about some of these points that should be present in your written HAZCOM plan. It should identify the personnel that are affected by the hazardous chemical. It should describe the hazards that you might encounter in your particular job. It should give the criteria for the labels and the SDSs. Usually it's going to say whatever OSHA says should be there, that should be there. That's what mine says anyway, because I didn't want to write all that 2 times. It should describe whatever specific training criteria is necessary for your particular job. That's called job-specific training. A list of your hazardous chemicals present. Okay. Now, when it comes to avoiding the risks associated with using hazardous chemicals, your first and best option is always going to be to engineer the job in such a way that you don't need a hazardous chemical. We do this frequently in chemical manufacturing when we discover that we can reformulate and remove a hazard and still have an effective chemical. So one of the first things that you would want to do as an end user of those products is to see if there is a version of that particular chemical available in the marketplace that is not hazardous. That's called engineering the risk out of the job. Okay? However, if that is not possible, then the next thing is to put processes into place to minimize your contact with that chemical. Okay? This could be something like engineering a closed delivery system if you need to introduce a hazardous chemical to a given spot over and over again. We do this in manufacturing. Okay, we have a closed loop system with a pump. We're able to tell that system to deliver a particular amount of that chemical to a particular tank. It's a closed system. My employees never come in contact with the actual chemical. That would be your second option. The third is to use the appropriate PPE. Again, you may find indications of which personal protective equipment is appropriate for that particular chemical on the label, but you may not. That is not a required thing on the label. So again, I would refer you to the SDS to make sure that you know which thing is appropriate to use. There is a big difference between a face shield, safety glasses, and safety goggles. Okay? They are not often interchangeable as one example of making sure you're using the correct PPE. So always be sure that you know that you are getting the right equipment to protect you from the risk inherent in that chemical. Same with respiratory protection. There are several different kinds of respiratory protection. There's a dust mask, there's a half-face respirator, there's a full-face respirator, there's a fully enclosed breathing apparatus. Okay? Again, it's important to know which one is appropriate to use with that chemical and which one you are trained and authorized to use. Another thing that's important to know is what is the appropriate response if this chemical is spilled. Generally, you'll find this spelled out very completely on the SDS. And some of the things that you may be instructed to do are to flush your eyes, if you get it in your eyes, to wash your skin with soap and water or remove contaminated clothing. If you've inhaled it, to either move yourself or have your coworkers move you to fresh air. If you have swallowed it, to get you emergency assistance. Some chemicals recommend that vomiting be induced, and some do not. The ones that do recommend vomiting to be induced have different things they want you to use to cause the vomiting. Usually that's because they want to begin neutralizing the chemical at the same time, and there are specific chemical reactions they're looking for. You do not always give someone water because they've ingested a chemical. So very important that you know the appropriate response in case someone has ingested the chemical. Always, always call for emergency medical assistance with ingestion. All right, another little test to see how we're doing so far. Chemical labels supply the most detailed information about a chemical's hazard, yes or no? No. What does? The SDS. Okay. The SDS has 16 sections, which we didn't get to look at. Yes, that's true. Okay. PPE is always the first line of defense against a chemical's hazards. False, yes, very good. You know, my guys get that one wrong all the time. I don't know what's up with that. The supplier information can be found on the label. The person who made the chemicals information can be found on the label. True? False? True. The hazardous chemical list is a part of the written HAZCOM program. Can you find a list of the hazardous chemicals in your HAZCOM written program for your department? Yes. Yes, you can. Or you should be able to. Okay? Doing all right? All right. Does everyone understand what to look for on a chemical label? We can review if we need to. What's the first thing you should always check for? Do you remember what I said? The pictograms, yes. Look for that first. That is a spot-on nanosecond indication whether you need to read that label more thoroughly because it might be hazardous. Okay. Again, I urge you to look over an SDS so you'll be familiar with where things are located. Okay. You've learned, hopefully you knew that there was a written hazardous communication program. If you didn't, then you've got something new. Okay? If you already knew that but you haven't read it yet, again, I urge you to read it. It's very important. It's part of your employee responsibility to know the information contained in it. You've learned that engineering and work process controls are important to minimize the risks when you are handling hazardous chemicals. That there are different levels of protection. Remember, we talked about the difference between goggles versus face shields or dust masks versus respirators. Different levels of protection. Okay. Some things to remember. The purpose of hazardous communication is to make you safer. We don't want any of you to be hurt. The GHS system is intended to standardize information about hazardous chemicals so that it is more available and easier to understand across the industry. That there are physical and health hazards associated with hazardous chemicals, depending on the chemical that you are dealing with. And that the information about that chemical is on both the label and the SDS, but more thorough in the SDS. And that your PPE and process controls can reduce the hazards that you are exposed to. I'm done. I believe that we are intending to have a question and answer session. Am I handling that, or we have some other health and safety officers who are going to come forward and field questions? Okay, just open it up. Anyone have any questions? Wow, I must be good. Yes. Yes, because OSHA is an American organization, they are only addressing the two words in English. Manufacturers have to determine whether they need to put other languages on the label. Certainly, if you are exporting products, or if I am exporting products into Canada, to Quebec, I'm going to want